So we want to write a test that has these three requirements. A simple way to do this is to write a new function for each of those three requirements, and then our test function can just iterate over the elements in our list and see if each element meets all of those three requirements. So what we can do is go back to the program we had before. Let's get rid of this line that was printing the result because we're not interested in that. Instead, we're going to do our testing. So I'll make a little comment here that says here's where we're going to start our testing code. And what we can do is define a placeholder method for each of these three requirements that we'll then use. So the first one maybe is write values. That is, given a list of random numbers and the specified maximum number, are all of the elements in the list the right values? Okay, so we'll write that. There's a special keyword we can use in Python called pass, which just means, well, don't actually do anything, just pass on, but a function definition needs something, so if you would just leave it blank, you'd get an error. So pass lets us go on without actually doing anything. The next one will be is write length. In this case, we only need the list. We don't need the maximum value because that's not going to be relevant. Pass. And then the last method will be is all unique. So, given the list of random numbers, is each random number different than all of the others? Again, we haven't written this yet. Alright, but once we have those three methods, now we can write our test. Test rands, and it's going to have to take the list of random numbers, the maximum value. It's also going to have to take the rest of the specified number of maximum numbers, and then we can go ahead and check to see if all three things are correct. So we can say if is write values. Notice this completion mechanism will automatically give us the option, so I don't have to type it all in. I can just go down to one of these that I want and press the tab key and it will fill that in. So if is write values, which takes rands and max, that's the first step. We want to also check the other one. So how do we check three different conditions? Well, we can use the AND operator, right, to put all three things together. So if it's the right values and is right length, and as I'm doing this, I realize we made a mistake. To check whether rands is the right length, it needs to know what the length is supposed to be. So we're going to have to put in the number of rands here, and then go back to is right length and put another parameter, which is number of rands here. Okay, and the last thing is all unique. So we'll say and is all unique, give it the rands. If all of these three things are true, then we can return true. Otherwise, we return false. Alright, we've got our nice testing method in place. It won't actually work yet, of course, because we haven't defined these methods. And I need a colon over here. We can try running it now and see what happens. To do that, let's call our testing method. Test. Well, I guess we need some random numbers, right? So to do that, let's define a variable which is the maximum that we want to test. Say we have a maximum of, say, 10. Numrands equals 5. And now let's generate some random numbers. Random numbers equals the non-unique rands, and we're going to pass in the number of rands it needs, and then the maximum number. And now we can test it. Print the result of calling test rands, where we pass in those rands, the maximum number, and the number of random numbers. And when we run this, it says false, because each of these three conditions didn't return true. They just passed. They didn't return anything at all. So until they each return true, we are not going to have a proper test result. So while we're developing this, it might be more convenient to test each of these three requirements one at a time. So I'm going to comment this out, and instead let's just call the first one, which is print the result as is right values. And we'll pass in the rands and the maximum number. If we do this, we still get a value that is not neither true nor false. It prints none, because when you do pass and you don't return anything, then a function isn't returning anything at all, so you get the special value of none. But now we can go ahead and implement isRight values. So let's start by implementing this in a very simple way. We can just write a for loop to iterate over all of the items in the rands list for item in rands. Right? So this will now loop for each item in the random number list. We'll say if it's greater than max, then we've got a problem. So we'll return false. The random numbers doesn't contain all the right values. So if item is greater than max, return false. Else, well, this is a little bit tricky. We can't actually return true here because we're only on the first item in the list. Just because the first item is less than max doesn't mean that all of the items are correct. So we actually don't want to return true here. That would be incorrect. Instead, what we want to do is iterate over all of the items in the list. If any of the items are incorrect, it will return false. If we've gotten through the entire list and it hasn't returned false, we've gotten to the end of the for loop, then we know that all of the items must be less or equal to max, and so we can return true. And I think this is a correct solution. Let's try running this, and look at this. It says true. It printed true, remember, because that's the result of calling isRight values, and every time we run this, in fact, it's going to return true, because we are, in fact, always generating good values. Let's introduce a bug in our program and see if our testing harness will recognize it. Instead of generating random numbers between 1 and max, let's generate numbers between 1 and 2 times max. That is, we're actually going to put in random numbers that are sometimes too big. Let's run it again. And look at this. Our testing harness is excellent. It is recognizing that we've got a problem, and it is saying false. Let's fix our program. Now our testing harness says true, so we're good. And we're ready to check the next thing, which is our list of random numbers the right length? To do this, all we need to do is have a way to find the number of items in a list. Well, we could iterate over the list and make a variable that counts how many items in the list, but it turns out we don't have to do all that because there is a function built into Python which returns the length of a list. And that is simply len. So we can say if the length of rands is equal to numRands, then we're good. Right? That's what we're aiming for. We return true, otherwise we return false. We think our testing code is correct, so when we run this, we need to check this one. Instead of checking isRight values, we'll now check isRight length and pass in rands and numRands. And now when we run it, we get true because our code is doing the right thing. Let's introduce a bug. Instead of adding exactly the right number, let's add an extra one. After this for loop, let's append the number 3. So now we'll always have one too many. And when we run our testing program, sure enough, it says false because we're always generating too many items in the list. So let's get rid of this bad line of code, run our test again, and it turns back to true. Okay, we're getting close. All we have to do now is implement isAllUnique. This one's a little bit trickier.
So how do we determine if every item in the list is unique? Well, think about how you would do this yourself. If you were to look at a list like this, you might just look at each number in a row and see if it is the same as any of the previous numbers. So the first number is always unique because it's the only one. Then when we look at the second number, we can compare it to the one before it, to the first number, and we say, nope, that's unique. Then for the next number, we compare it against the first number and the second number. It's unique, right? It's different than both of those. And for the last item on the list, we check it against the first number, and whoops! We found another instance of the same number on the list. It's not unique, so therefore we have an error.
So now let's see if we can go ahead and implement the algorithm that we just developed. What we're going to do is iterate through all of the items in the random list. So for item in rands, now what we want to do is check all of the previous items. So in order to do that, we have to know where we are in the list. So we're going to have to keep track of that by making a new variable which we can call index, which is where we are in the list. So we start off at index equals 0, and for now we're at index 0, right? And then afterwards we'll increment index. So what we need to do is now check the current item against all of the previous ones. So how do we get the previous ones? Well, we can iterate through the list again, starting at the beginning of the list, going up to everything before the current one. And we can do that with slices. So we can look at the previous item in the list, but we don't want to go through the whole list. This is the trick. What we want to use is slices to go from the beginning of the list up to just before where we are. Well, remember how slicing works. The second item in the slice tells the slice to take everything up to but not including that one. So in fact, that's going to give us all of the previous items not including this one. Now we can say if that previous item equals the current item, that means we found a duplicate. So that's bad. We're going to say false. Everything is not unique. If, on the other hand, we go through all of these things and we don't ever return any falses, then we're done. So we go out of both loops and we return true. So to summarize, this first loop is iterating through every item in the list, and then for each of those items, we're going to do the following thing. We're going to check all of the previous items, that is everything on the list up to but not including the current one. And for each one of those, we're going to check, is that item equal to the current item? If so, we found a duplicate. Everything is not unique, so we return false. At the end of this first loop, we increment our index, which keeps track of where we are. And then when this whole first loop finishes, which means we've gone through all of the items in the list, compared it to all the previous items, haven't found any duplicates, so therefore we can return true. Let's go ahead and test this. So we will call this function and print it. Is all unique? Pass in our rands. We think it's correct, so when we run this, we should get true, but we don't. We have false. Why is that? Oh, of course, we haven't implemented non-unique rands properly, right? Unique rands properly. We're actually generating non-unique randoms. So in fact, this fails because we don't have a good solution yet. All right, so anyway, now that we've implemented these three requirement tests, we can now instead call our overall test rands, which brings all three together, and this should still return false. And sure enough, it is false because it's calling all three tests. Some of them pass, some of them fail. Now, if we built a better testing harness, it would tell us why something is failing. In fact, maybe that's a good idea. Maybe what we should do is go and put in each of our tests a print statement that will print if something is false, why it's false. So for each of those, we'll do that. Is right values, we'll say print. And we'll say something like wrong value. And we'll say what the wrong value is. It's item, the one we were just checking. Okay? Maybe we can even give a little bit, well, yeah, maybe we'll give a little bit more information and say something like max equals. So we should know what it's supposed to be. Right? And concatenating all of these elements together, I even put a little space here, so it'll print a nice max equals what the maximum value is supposed to be. Similarly, if it's not the right length, we'll say print wrong length. And we'll say the actual length is length. Oh, got a plus sign there. While length is supposed to be numRands. Okay, and finally, are they all unique? When we return false, we'll say not unique, and we can just say which number is not unique, which is item. And then just to make this a little bit prettier, maybe when our testing, instead of returning true or false, we'll just print something a little bit nicer. So instead of returning true, what we'll do is we'll print true and then followed by the list. Similarly, instead of returning false, we can print false followed by the list. And now, instead of printing testRands, we can just call it since it prints stuff out itself. And now when we run it, we'll get some more information. Okay, we have a problem because I have the same bug I have had before, which is that you cannot concatenate strings and integers. I do this all the time. So what we have to do is go back to all those print statements we just made, and every time we printed an integer, wrap it around str, the str function. Try again, and there we go. Not unique, 5. Sure enough, false. 5 is duplicated. Cool, let's try running it again. Not unique, 10. Correct. True! We happened by pure luck to generate a completely unique list of random numbers, and our testing harness worked. Alright, now that we have a good testing harness, we can go back and try and implement our random number generator so it actually generates unique random numbers.